Okay, guys. Today what I'm going to do is I'm going to give you an overview of the kidneys, and I'm going to explain to you the functions of the kidney, and then we'll go over some pathology. First of all, this is the basic structure of the urinary system. You have two kidneys. Then connected to the kidneys are these hollow muscular tubes called ureters. So very simply, the kidney filters the plasma of the blood. What is filtered is then drained through these hollow muscular tubes. So they contract and relax just like your intestines, and they propel that urine down to the bladder. And as the bladder fills up, pressure builds up, and it will cause you to have to pee. So the reason the right kidney is lower than left is because you got this guy here, your liver, in the right upper quadrant of your abdomen. So that causes the right kidney to be slightly lower than left, and it's actually a little bit smaller than the left. So if we look at this for a minute, what I want you to understand is the primary function of the kidney, or one of its big functions, is to filter the plasma of waste, metabolic waste. And the two big waste products that the kidney has to get rid of are urea and creatinine. So I'm just going to give you a brief little summary of how you make those. Now, here you go. You got your liver. So you eat, you eat a quarter pounder, and that has protein in it. And that protein from the diet gets brought into the blood through the intestines via the hepatic portal vein. So everything that you eat goes through the liver on the way in and on the way out. So the liver filters the blood. So you got your protein from your diet, and protein has this nitrogen compound. That nitrogen compound is called the amino group. So when you eat protein, we know that proteins are made of amino acids. So the amino acids go to the liver, and then they get this amino group hacked off. And that is then converted into ammonia. And ammonia is bad for you. So what the kidney does then is converts it to urea, which is less toxic and it's water soluble. And then it leaves the liver and then enters the general circulation. So you can't breathe out urea. So one of the things that the kidney has to get rid of is that urea. So because urea contains nitrogen, this urea waste product is referred to as blood urea nitrogen, or BUN. Now, the other waste product is from the breakdown of this compound called creatine phosphate. Creatine phosphate is the stored form of ATP in skeletal muscles. So you got to have a little energy stored inside those muscles. So if you got to run real fast from the Hamburglar, or whatever. So when creatine is broken down, it's broken down to the waste product creatinine. And creatinine has to be gotten rid of. And you can't breathe out creatinine, so the only way that you can get rid of it is by filtering it out of your kidneys. So the kidneys have to get rid of that creatinine. And they do that by filtering it out. Now, look, and this is important. Blood urea nitrogen. One of the things that determines the amount of blood urea nitrogen in your blood is the amount of protein that you take in. So the more protein you have in your diet, the greater the BUN is going to be. But for most people, creatinine levels don't change. And the creatinine level is determined, it's based on your muscle mass. So you don't wake up one morning and you're a pencil neck geek, and then the next day you wake up and you're like just muscles all over, right? So muscle mass doesn't change very much. Therefore, creatinine is really the best indicator of kidney function, and that's what physicians look at to determine if someone's kidneys are failing or if they need to go on dialysis. So the two big things, the two waste products that the kidneys have to get rid of are blood urea nitrogen, which is a byproduct of protein metabolism, and creatinine, which is a byproduct of skeletal muscle breakdown that's stored ATP. So, I mean, just thinking about it, right? If your kidneys ain't doing so good, do you want to tax your kidneys? Do you want to make them work harder? Nope. So that's why people who are going into kidney failure, renal failure, they're instructed to go on a low protein diet. That low protein diet, right, will prevent the kidneys from having to work harder than they need to. So that's one of the big functions. The other big functions of the kidney, right, are that they maintain fluid levels, right? They maintain the correct amount of water you got in your blood. So if you drink a gallon of water, what are you going to have to do in a few minutes? You're going to have to pee, because the kidney is involved in maintaining that fluid balance. The other thing that it does is it maintains electrolyte balance. So you got to maintain your sodium, potassium, chloride, calcium, all those things. So it maintains electrolyte balance. And I'll explain more about that a little bit later. The other thing that it's intimately involved in, so number 3, the kidneys maintain long-term pH. So we talked about this, that the kidneys can correct any pH disturbance in the body if the person lives long enough. That's why when people are in the hospital, especially in the ICU, and they're doing really bad, right, they're in shock, right? Their cardiovascular system's beginning to fail. Well, what the physician wants to do is try to keep that cardiovascular function good enough to maintain blood flow to the kidney, because they know that the kidneys can correct any pH disturbance if you live long enough. So then the other function of the kidney, number 4, is that it monitors oxygen saturation of the blood. So it measures how much oxygen is bound to hemoglobin, right? Little red blood cell carrier. Now, if the kidneys note that there's a drop in oxygen saturation, the amount of oxygen in the arterial blood is dropping, then the kidneys will release a hormone into the blood called erythropoietin. And poietin means not eating well. Oh, no, it means to form red blood cells. So what erythropoietin does is it stimulates the bone marrow to make more red blood cells. The other thing that the kidney does is it activates vitamin D. And vitamin D is needed to absorb calcium from the gut. And then finally, and we kind of talked about this, one of its major functions is to maintain long-term blood pressure. Right? So just watch. If you know somebody who is on dialysis, these people cannot drink as much fluid as they want. They're on a fluid restriction because one of the jobs of the kidney is to maintain fluid and electrolyte balance. And fluid that you take in can increase your blood pressure. So if you can't pee that fluid out because your kidneys are failing, then you want to make sure that they limit the amount of fluid that they take in. Now, again, very important. Anytime an organ fails, all the functions of that organ fails. So they're going to have problems with blood pressure, pH, electrolyte disturbances, right? Making new red blood cells, and getting calcium from their diet into the blood. Because, again, if you understand the functions of the kidney, then you'll understand that when the kidneys begin to fail, all those functions begin to fail. So let's take just a little bit of a closer look at the inside of the kidney. Okay, what we're looking at right now is a cross-section of the kidney. So I just want to go over some of the internal structures of the kidney and just give you an idea of what's going on. First of all, the kidney is divided into basically two parts. You have the outer portion, and the outer portion of any organ is called the cortex. And then you have the inner portion here, called the medulla. So now this is important. You have the renal artery, this large artery that comes off the abdominal aorta, and as you can see, the renal artery enters what's referred to as the hilum of the kidney. The hilum of any organ is where major blood vessels, nerves, structures enter or exit an organ. So in this case, the renal artery comes in, and as you can see, it begins to split off into smaller and smaller arteries. So it is, in fact, the arterial blood that is filtered by the kidney, because the arterial blood's under pressure. And when I explain the function of the nephron, that will make more sense. So as you can see here, and I'll show you a better picture of it in a minute, this guy right here is the nephron. And both your kidneys have anywhere from 1 to 1.5 million of these nephrons. So when these things start jacking up, you're not able to adequately filter your blood, and the result is renal failure. So once you've filtered the plasma of the blood with this little nephron guy, then whatever the kidney or the nephron filtered, it then leaves and enters this area called the renal pelvis, kind of like a little collection area for all those 1 to 1.5 million nephrons. So this is where the urine is formed. And then as you can see, the urine then drains through that hollow muscular tube called the ureter, and then into your bladder, and then out the world, to the world. So the nephron filters that plasma, and then the blood that has been filtered leaves the kidney and enters the general circulation through the renal vein. So let's look now at the basic and most important functional unit of the kidney, and that is the nephron. So let me give you an overview of this, and then we'll get a little more specific. Now, as you can see, you have this little yellow brick road, right? The yellow brick road. These are referred to as the collecting tubules. So when the blood is filtered, it's filtered out of the blood and into these collecting tubules. And each portion of the collecting tubule has a specific function. I have a video specifically on the nephron, so I'm not going to give you a lot of detail here, but I do want to say this. Now, watch. It's the arterial blood that enters the beginning portion of the nephron. That beginning portion of the nephron is called the glomerulus. Glomerulus literally means a ball of capillaries. So if we learned, these capillaries are one cell membrane thick, but in the case of this glomerulus, it actually has more slits in it than a normal capillary. So think of the glomerulus as kind of like a spaghetti strainer. So when blood comes into the nephron, it will filter the plasma. So the small stuff, the electrolytes, amino acids, vitamins, right? Urea, creatinine, ammonia, all of that stuff is going to get filtered out of the blood, right? Electrolytes. And whatever is not filtered then leaves the glomerulus. And then this artery, called the efferent arteriole, efferent away, it forms a network of capillaries surrounding the little collection tubules. And those little capillaries are called peritubular capillaries. So to make urine, 3 things have to happen. All right? Number 1, you have to filter the plasma. So you're going to be filtering the watery part of the blood, right? You don't pee dust. And you're going to be filtering some of the small particles like electrolytes and vitamins, minerals, right? Creatinine, ammonia, urea, all of that stuff is going to get filtered and then end up in the little yellow brick road. So that's the first portion of making urine. You've got to filter the plasma of the blood. Now, stuff in the blood that's too big to get filtered by the glomerulus remains in the blood. So what's big in your blood? Well, red blood cells, white blood cells, and big proteins like albumin. These guys are too big to fit through the little spaghetti strainer, so they should never be found in the urine. So if you're peeing blood, you're peeing pus, or you're peeing albumin, right, a lot of proteins, then there's something major league wrong with your kidneys. Now, after you've filtered the stuff, now think about it for a minute. Watch. If you're going to clean your closet, are you just going to pick stuff out and then throw it away? No, what most people do is they take everything out and then they decide what they're going to put back in. So the nephron does the same thing. It filters the plasma, right? It filters all the plasma that came into it. And then, as that filtered plasma travels through the yellow brick road, the kidney decides, the nephron decides what it's going to bring back into the blood. And it's based on the needs of the body. So the second thing is you have to reabsorb stuff. Now, it got absorbed into your blood when you ate it from your GI tract. Now it's in your blood. Then the nephron filters it out of your blood, and then you have to bring it back into your blood. So if it was already in the blood, then it got filtered out by the glomerulus into the little collecting tubules, and now it has to be brought back in. So that's why it's reabsorbed, right? And then finally, some things in the blood just can't be filtered by the glomerulus. I'm not going to get into why, but the two big things that have a hard time being filtered by the glomerulus are potassium and hydrogen ions. And those have to be actively secreted. So they remain in the blood, and if the nephron wants to get rid of them, you got to push them out into the collecting tubules so they can be peed out. So after you filter the plasma, whatever's filtered into the yellow brick road, that has to be reabsorbed. And then finally, some things can't be filtered, so they have to be secreted. So you filter it, what you want back, you reabsorb, and then what you don't want, you want to secrete. So what's ever left over is your urine. So, and different parts of the nephron will absorb different things, and we can worry about that later. So that's a real basic overview of the kidney. Now what I'd like to talk to you about is the basic structure of the ureter and the bladder. So let's do that. Okay, so talked about a little bit about the kidney. Now, once the kidney makes urine, it's drained into these hollow muscular tubes called ureters, and then it's drained into the bladder. And these are hollow muscular tubes are made of smooth muscles, and they will rhythmically contract and relax, just like your esophagus, to kind of move that urine down by peristalsis. You don't want the urine just to slide down the tube, because if you stand on your head, then the urine that's in the bladder can back up. So that's why you have that peristaltically waving. Now, a couple of things about that. Number one, if you happen to get a kidney stone, and it gets lodged in the wall of one of those ureters. And again, kidney stones aren't like period boulders, they're like ninja Death Stars, right? They're sharp and jagged, and they can actually dig into the lining of that ureter. And if that happens, you will get pain. It's called renal colic. Basically, every time the ureter goes through those peristaltic waves, that is going to cause shock waves of pain, right? Very, very bad for you. And then finally, you have the bladder. And the bladder is a hollow muscular organ. And if we look a little closer at the bladder, you're going to see that the ureters, they actually come underneath the bladder and empty underneath, so the urine kind of bubbles up here. Now, here's the important thing to know, is that you have an internal sphincter that's under autonomic control. So let me give you an example. You're sitting in class, bored out of your skull, and your bladder fills up. And when you fill up enough urine in your bladder, it's going to create pressure, and that is going to say, okay, I better go. So you have this internal urethral sphincter that's under conscious or autonomic control, meaning it's going to begin to relax. But you say to yourself, ooh, I can't go because this stuff's really interesting. So you have an external sphincter that surrounds the urethra, and you can keep that contracted until there's a more appropriate time to go. So as people age, the external sphincter becomes weakened, so they can't control it, right? Can't completely cut off urine supply. That's why a lot of older people get stress incontinence. Pregnant women will get that because the baby rests right on top of the bladder, and that will put pressure on it and make that muscle, can weaken that muscle, and that can lead to stress incontinence. So that's kind of an overview of the urinary system, the functions of the kidney, and some brief anatomy of the ureter and bladder.